Okay, we're going to talk about the differential. Now, I'm intending this as a review for people who've completed a calculus course, but I have a question here that should be answerable by anybody who's completed the prerequisites for a calculus course. Whereas my experience is that most students can't answer this question even having completed a calculus course. So anyhow, here's the question. You should read it and attempt to answer it yourself. And if you can't give a good answer to the question, you have a lot of company. So hopefully you paused and did that. Let's deconstruct the question to see what it's asking. Okay, so we got y equals 4.7 when x equals 12.3, and we want to find how much y has changed by the time x equals 12.5. So y equals 4.7 how much does y change if x changes from 12.3 to 12.5. Now we might want to write down that x equals 12.3 implies that y is 4.7. That's stated very clearly, but let's make sure that we understand that. Okay, well, how we're going to answer this? But when we put it this way, is there anything that occurs to us that didn't occur to us before? Well, yeah, and you might well have done this, but the point is x changes by 0.2. So we have a change in x of 0.2 from 12.3 to 12.5. What is the one thing that we need in order to figure out then how much y changes? Again, you should pause and think about this. Okay? The rate of change of y with respect to x is 21.6. Now, what do we mean by the rate of change of y with respect to x? People get through a complete calculus course without understanding what that means or why it's important. Although I think maybe a majority, probably a small majority, but a majority probably do have some sense. Okay? So what do we mean by the rate of change of y with respect to x? Well, the rate of change of y with respect to x equals the change in y over the change in x. Now, that's not exactly equal. The rate of change, the instantaneous rate of change, is a limiting value of delta y over delta x, and that's your definition of the derivative. But I'm just going to say it's approximately equal to delta y over delta x. Or we could say the average rate of change of y with respect to x is equal, no approximate anymore, to delta y over delta x. The idea is simply that a rate of change of one thing with respect to another is basically a change in one quantity divided by the change in the other. So if the average rate of change of delta y with respect to x is 21.6, and if we know delta x, then we should be able to find delta y. Now we have to be a little careful here with our terminology. We can say again that x equals 12.3 implies that at x equals 12.3, this is the average rate of change. So now we can say if the rate of change, and let me change colors here just to brighten your day, to indicate a transition. If the rate of change, and we mean now the rate of change of y with respect to x, and I'm not going to write all, well, maybe I will. If the rate of change of y with respect to x itself doesn't change much, between x equals 12.3 and x equals 12.5, then we can say that the average rate of change of y with respect to x should be pretty close to, what is it, 21.6 on this interval. So our conclusion is that delta y over delta x should be approximately 21.6. And knowing that delta x is 0.2, change in y should be 21.6 times change in x, which is 21.6 times 0.2. And that's approximately equal to 0.43. It's 0.432 if I did my arithmetic correctly. And actually, I'm wrong about that. I've got the decimal in the wrong place. Let me fix that. Okay. So the change at y should be 4.3, so that y, when x equals 12.5, implies that y should equal its original value, 4.7, plus the 4.3, which would be 9.0. Okay, now, an abbreviated reasoning for this problem, and if you haven't thought about these problems enough to immediately think of the abbreviated reasoning, if you've got to think through all these steps and definitions, then you need more familiarity with the situation, with this kind of thinking. Okay, because this kind of thinking is very basic to calculus and its application. So, abbreviated reasoning, rate is 21.6. X changes by 0.2, so y changes. Got to do a little abbreviating here, by 0.2 times 21.6. And the rest is just obvious. I'll put the etc. there. So if you know, if you calculate this, you're going to get 4.3, and then you're going to add that. If y changes by 4.3, then it starts at 4.7. You're going to add the two together to get the new value of y, the new approximate value of y. Now, remember one important thing. If this is dependent on the idea that the rate of change of y with respect to x doesn't change much, So if the rate of change of y with respect to x doesn't change much, then this reasoning is important. This reasoning is reasonable. This result is going to be reasonable, and it's going to be accurate to the extent that this is the case. If it doesn't change at all, then this is going to be more or less an exact, at least to the number of significant figures we used here, it's going to be more or less an exact result. If the rate varies significantly between these two values of x, then not so much. Okay, and you're probably going to need to use a smaller interval of x to make an estimate.